Take 14. In this tutorial we're going to look at how to create buildings for physical models. This means you don't have to use laser cutters and 2D, you can actually create it in 3D in a cheap and effective way, saving time and money. So we're going to look at two options on how to do this in 3ds Max and just see how they go when we send them to the 3D printer. So let's start with standard primitive. Let's go with a box. And we'll just change the parameters of that so that they're 30 meters by 30 meters by 80 meters. We'll make them 6 segments by 6 by 6. Okay, the first way we're going to create this building is by putting a number of modifiers on. So let's start with a subdivide modifier. Okay, there we go. We can see that's added quite a few polygons. Next, we're going to add a mesh smooth. Alright, now with mesh smooth, we've got to make sure that the subdivision method is classic and that the smoothing parameters are set to 1. Okay. Next, we're going to put a vertex world on. And we're going to change that threshold to 1 as well. Okay, on top of that we're going to put an edit poly, and edit poly will select animate, select polygon, and we'll just go and select all the polygons. Now edit poly allows you to then inset on each of those polygons, so select inset, go to the icon there, that takes you to this icon in the middle, go by polygon, let's change it to 0.3 and select. Okay, and that's just left us with what will be a mesh shape when we delete the mesh. So let's go delete mesh. Now we can see we've got a number of polygons all put together with a lot of empty space, but overall it looks like a building. So we need to thicken up these walls, so we're going to do that by adding a shell. Alright. Make these a bit more rounded. So we're going to do a turbo smooth. Okay, that's looking better. Quite interesting geometry there. And we might just increase the polygon count a little bit. Smooth it out a bit more. Make that 2. And now we have a very interesting shape. You've got to be very careful with turbo smooth. It does make the computer go very small. It does make the computer go very slow, but you can see why I've got such an interesting shape there. And hopefully that will print off with the 3D printer just like that. And we'll be able to put that into our physical model. The second way we're going to experiment with these mesh shapes is a lot simpler, but we do have some concerns about it. So let's go back to standard primitives, create a box. Okay, let's give it the same parameters, 30 by 30 by 80. Segments will keep the same. Might make it a bit more interesting this time. In modifier, let's give it a bit of a twist. just a little bit there. So that's the angle, slight twist there, and we might give it a taper. So let's look at how we do this. A slight taper like that. Just a bit different. You can see I'm a landscape architect. And finally, to get the same mesh, we're just going to try and do it through creating a modifier of a lattice. Okay, so there's our lattice, and instantly you can see that it's not really the shape we want, so we're going to reduce our joints right down. Okay, and it's starting to look a bit more like a building. We might and just bring those the radius of the struts down to 1 meter. Okay, now here there's a few concerns. With the 3D printer we need to have a closed object, and because we've got such small nodes, you can see here that the 3D printer may reject this model. So what we're going to do is just increase the radius to 1 meter. That's closed it somewhat, but still looks a bit dodgy. So we're just going to increase to say 1.2. Not entirely sure this is going to work, but worth a try anyway. And we might just try and make these a little less square, these struts. So I'm going to add a tessellate. Alright, that's given it a bit more thickness. Looks like it's a bit more watertight. We might just increase that a little bit. Alright. So there we have it, 2 mesh models that a 3D printer will hopefully recognise. And they won't cost much to print because there's so much blank space. But in a model, they would look like quite a nice addition, particularly if you made quite a few, and as we saw, you can actually do some interesting things with them. So before we send it to reduce the scale so that they are at a size that the 3D printer can actually print at. So what we're going to do is change the viewport to front. There's our 2 buildings. We've got the first one here, which we'll just select. We've got scale selected there, scale, and then we're going to go 0.1, 0.1 and 0.1 on the 3 axes down the bottom here. And then what we've got is a much smaller building. That's in physical model size. So just to check the size, what we can do is select the object, and then quite handy feature is to go select this one here, the hammer, select measure, and then we've got our dimension. So now we know this is 9 centimeters tall by 0.3 by 3.9 and 3.9 centimeters on the X and Y axes. So the volume, which is actually what we're going to be paying for the printing of this, is sort of unknown at the moment, but hopefully it's not so small that the 3D printer can't manage it. Alright, let's go and repeat that with our second building, which is here. Select that, scale, 0.1, 0.1, 0.1. Alright, let's have a closer look. Okay, and there he is. Okay. So, this one, 8 centimeters by 3 by 3. So that's good. Good size to be printing. Okay, now I've got these two buildings to scale. We want to export them at the right, as the right file extension. So we'll select them, go to export, and we're after STL file. We'll call this a mesh building. Save it on the hard drive. Okay, okay. Now we go to the FabLab website. There she is, the beautiful big 3D printer, and we just enter our details there, add the file, and off it goes. Now we can't do this remotely, so I'm going to have to do it at uni, and I'll report back on the success or failure of this little project. But thanks for listening.